interesting shape over here, right? And we want the area of this little piece over here. Does anyone have an idea how we're even going to go about it? Let's first start off with what shapes are we working with here? I think that's the best place to start when we're doing such questions. A circle, definitely. And a triangle. Beautiful, beautiful, guys. So, generally in these questions, you first want to find the area of the big shape, right? And the big shape we have identified as a circle. So we're going to say the area of the circle. Why is this so? I can't see. There we go. Area of circle. And my formula, as we know, is pi r squared. We're still using pi is equal to 3,14. Okay, so let's get substituting. So that is pi. What's my radius for this circle? What's my radius for this circle? It is indeed 10 centimeters squared. Okay, this can actually be done with mental maths, guys. What's 10 squared? How much is 10 squared? 100, ne? Which means that my area is what? We're just moving the comma. There we go. 3,314, excuse me, 314 centimeters squared. Now we get to the interesting part. How are we going to remove this part? How are we going to work out the area of that part in order to find out the area of my shaded region? First, I need to figure out, we don't actually need Pythagoras for this, believe it or not. We do not need Pythagoras, right? We need to find the area of, firstly, this part of the circle, which is what fraction? What fraction of the area is, I'm talking about these three. Oh, I see what Alice is doing. I see what Alice is doing. Alice, that is actually a method that I never thought about. That's a method I never thought about. Do you agree that if we find a quarter of the circle, this will give us this part? Do you guys agree with that? And then we can just minus the area of the what? If we have that quarter of a circle, yes, then we can just minus the area of a triangle. Alice, you genius, you. Yeah, no, the test tomorrow, it doesn't know. It does not know. Does not know what's on its way. Yeah. Okay, so I'm going to go ahead and say, well, then 314 times a quarter, which gives me how much? I don't have a calculator once again, guys. What type of maths teachers? Because I keep borrowing learners who do tests. You guys forget your calculators. But what's a quarter of 314? 78,5. I feel like Alice is guilty of what I'm talking about. You guys always leave your calculators. They say, ma'am, can you please borrow me a calculator? And then gone. Now I must go hunt those people. Okay, so we know that that whole blue part is 78,5. Now let's figure out the area of the triangle. Right? And the triangle is half base times height. Do we have enough information in this triangle to figure out the area? Yes, we do. What's the base? 10. And what's the height? It is also 10 because they are both radii. Do you see this? Look there. Over there and over there. Okay, and my answer is indeed 50 centimeters squared. So then the area of my shaded region, what am I going to do with these two areas? Nice. Nice, 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 nice. Jeez. 78,5 minus 50, which will give me 28,5 centimeters squared. Beautiful. Can we have a thumbs up, thumbs down on this one? That was too easy for you guys. I should have found more interesting questions, but it's fine. It's fine. It's okay. Okay, we all got thumbs up. Great. Now, find the area and circumference of this interesting guy over here. Hmm. Hmm. What have we here? What have we here? You know this question. That means you've done it before, Alice. That means you're going to guide us. Look, guys, we have Alice who's going to guide us through this question. Right? Trauma. It's not that traumatic. Let's start off with area. I think area will put everyone's minds at ease if we start off with the area. Now, if you look at this little baby circle here, if I say it can fit there, would that be an accurate statement or an accurate statement? If I say you can fit that little baby semicircle into the space, is that an accurate statement? Alice says yes. And what does everyone else say? Do you guys agree that that small semicircle fits into there? Marlene also agrees. Why am I saying this is not a generalization? Why do we know for a fact that that small semicircle will fill up the space in the big semicircle? How do I know that for a fact? It has to do with the dimensions. Look carefully. Not same radii, but you're on the right track, right? But the radius of the big semicircle is the what of the smaller one? The radius of the big semicircle is the diameter. Yes, guys. So if this semicircle was somewhere like starting over there, then no, it definitely wouldn't be the same size, right? But because we know that the diameter of this one is the radius, that means it will exactly fit into this space. So to make it easier, if I do fit it into that space, then what shape do we have? What will the shape just be? It will just be a regular semicircle. Do we see that, guys? It'll just be a regular semicircle. That means I can use the formula A is equal to pi r squared. Is that correct? As it is. Is that the correct formula? Yes, a half. Nice. Alice is very ready for this paper tomorrow. So that'll be, let's not waste space because circumference is going to take us on a different journey. Ne? So that'll be a half of 3,14. And which radius am I using? That's also another thing that's important to identify. Which radius am I going to use here? Rachile says 7. Just think about which area we are figuring out. The one of the big semicircles. So the radius is 14 squared. Nice, guys. Can we have calculator boffins out here doing their thing? What's the area? I'm going to try and work it out also on my side. But you know you guys have to confirm, right? Times. Yes, I got the same answer. 307,72 centimeters squared. Easy. Now circumference is going to take us on a very different journey. Ne? Remember, circumference means the outside of the shape. So that means this curve over here, terrible, terrible. This curve over here, and that one on the outside there. And there's a reason I'm using different colors for these curves. We'll determine why just now. And the blue part. Okay. Now, if you look at the two yellow parts that I have highlighted, what does that make you think of? What does that look like? The yellow parts. That makes you think of? Okay, not an issue. I'm talking about the circle, guys. The actual circle. If I put those two together, what's going to happen? They are one small circle. And we know that they are full circle because they have the same diameter. Does that make sense, guys? So it's just one circle. So I'm going to say area, not area, sorry, circumference of the small circle. And we can use our formula as it is because it is indeed a full circle. Are we with me, guys? So this will be 2 times 3,14. What's my radius of the small baby circle? Small baby circle, it's 7. Okay, so what's 2 times 3,14 times a 7? 43, 96 centimeters. Great. Now let's deal with the blue part here. Okay, so circumference of the big circle equals 2 pi radius. Is that correct? Is that the correct depiction of this formula? What's missing? What is missing in this case? Yes, it's the half. Now, I know you guys get formula sheets, and usually it would say plus diameter. Are we adding diameter in this case? Why not, Alice? You guys are on fire today. You came ready for me. Yo, I was never ready. I was never ready. We're not adding it because the diameter doesn't form part of the outside circle, the outside of the circle. Do you see that? This part is not part of the shape, and the other part of it is in the middle. So this is the full formula we're going to use, and this will then be a half of 2 times 3,14, and this time use the correct radius, which is 14. Okay, let's figure out circumference of big circle. That is also 43,96. Isn't that interesting? So then your total circumference will be equal to 43,96 plus another 43,96. And that equals 87,92 centimeters. Oof, I don't know what happened there. Centimeters. Great, guys. Are we happy? Can we have a thumbs up, thumbs down? Nice. Nice, 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 nice. Okay. That one is too easy for you guys. Let's move on to something three-dimensional. Three-dimensional. Okay. A company manufacturing solid chocolate bars has 2 new packaging containers that will have the same amount of chocolate. The one container is a triangular prism with an equilateral triangle as a base. What does that mean? What does that mean? If we have an equilateral triangle as the base, then triangles are the same, but what does that mean about the actual triangles? What is equal, Maureen? You're on the right track? The sides. Okay, so this one at the bottom is 3,15, but so is, 3,5, but so is this one, and so is this side. Great. The other is a rectangular prism. They want to cut down on costs of the card box used for making the container. Determine which one will be the least expensive. Okay, so obviously the one with the smallest surface area will be the least expensive. Okay, so we're working with surface area over here. So let's start off with surface area of, let's do the rectangular prism first. Okay, formula for surface area of a rectangular prism. Let's hear what you guys have to say in the chat. All my dimensions are in centimeters? Yes, we've checked. Always check that in a test. We always trick people with that. Formula for the surface area. I know it's a very long formula. Thank you, Leachilwe. 2 times length breadth plus 2 times length height plus 2 times breadth height. And now let's identify them, okay? What is my length in this case? What is my length in this case? 15, 5. Okay. So I always do this in a test just to make sure I am substituting the right things, okay? You don't have to use color. You can just write L equals. And my breadth, the breadth is 7. So that's going to go there and over there. And finally, my height is equal to 1. So that's going to go there and there. Great. Let's get substituting. So it's 2 times blue and yellow plus 2 times blue and green plus 2 times yellow and green. Great. Let's get working out, guys. You can do this all in one step, but you guys know I have trust issues with calculators. So I do it in step by step. Okay. So I'm just going to do this. I'll write down the answer now. I just want to write down what the individual ones are. Plus 31 plus 14. Alice, that is a very big number. 262. Don't be sorry. Centimeters squared. So we're done with the first one. Now let's do the surface area of the triangular prism. Do you see why I have calculator trust issues? That's why I do this, because you end up with a question that is with the answer that is hectic. Triangular prism. Great. What's the formula for that one? Let's see if you guys have a formula. We actually split this up usually, right? Because it's twice half base times height because of the two triangles. Plus, okay, now we need to name these guys. That's why I like to do it split. So let's actually split them. Okay, if you guys have one formula that you use at school, that's fine. But I like naming my rectangles. This one will be 1. The one on the other side will be a 2. And the one at the bottom will be our 3. Okay, so I'm going to say rectangular 1. Breadth times height. Oh, that's actually a very good. But my problem is, how do you decide which one is side and which one is breadth and which one is... So that's fine. If it works for you, then that's fine. But I like splitting it up still. I'm still a little baby. So rectangular 1, which is the one in front, my length times breadth will be 3, 5 times 21. Oh, wait. What's the trick here? They told us that this is an equilateral. So what does that mean about the areas of all of those rectangles? If they told us that this is an equilateral triangle, that means all of those rectangles have what? They are equal, so the areas are the same. Do you guys see that? Yes, all of the areas will be the same. So we actually don't have to go through all of this. We can just say a surface area of triangular prism is 2 times the half base times height because of my two triangles, plus 3 times the length times breadth, because the length and breadth will just be the same. Okay, So this is 2 times. Oh, what are we missing here? I just realized when I was about to substitute. What are we missing that we don't have? We don't have enough information for this. What is it that we're missing? The small height, your perpendicular height for your triangle. Okay, so if this is my triangle, I'm going to draw it on the side over here. And we know that this triangle is 3,5 at the bottom and 3,5 here. But we're only going to use one of these, right? So what is the dimension then of this little space over here? What will the dimension of that be? Because we're using the small triangle. We can't use the big one because it's not a right angle triangle. What will it be? 1,75. Thank you. Great. So then I'm going to name this A, B, C, and D. So then AC squared plus CD squared will give us AD squared. And your reason will be Pythagoras. Great. AC is what we're looking for. So I'm just going to leave it as AC squared. We know CD is 1,75. And we know AD is, and then I write AD. We know AD is 3,5 squared. So then AC squared is equal to what? What's 3,5 squared? 3,5 squared. We have 7 where? 12,25 minus what's 1,75 squared? 1,75 squared, 3,0625. That means my AC squared is equal to what's 12,25 minus 3,0625. Let's see, 12,25 minus 3,0625. That is 9,1875. And if I square root both sides, let's see, if I square root both sides, that means AC is 3,03 centimeters. Okay, now we have our height. So then it's a half of the base times the height plus 3 times my length, which will be the 21, times the breadth, which will be 3,5. Okay, let's get working. Again, I'm going to do it in little pieces because you know I have trust issues, right? 2 times 3,03. So the first part of this, I got 5,3025 plus 21,35. Nope, 21 times 3,5 times 3. I got 220,5. Maybe I made a mistake. Roa, your hand is up. Do you have a question? You can unmute. Or not. I got a different answer, guys. Can we have more people checking? Three times Oh, this is 10. I didn't double. I didn't double. I see what happened over here. So it's 10, comma 605 plus. There we go. Now it makes sense, right? I'm writing on the wrong place. Equals 231, comma. Did they tell us how to round this off? No, so we're just going to use two decimal places, which is just 1 centimeters. So, which one will be cheaper to use? Which of these packages will be cheaper to use? It is the triangular prism. So therefore, triangular prism is cheaper. Wonderful, guys. Can we get a thumbs up, thumbs down on this one? Nice. Okay, can we have a brain break? I don't put my clues. I went to fetch it and then I forgot to paste it. So it's somewhere in the abyss. The cruise is cruising somewhere. So let's do this. Because I know you guys are going to read the questions while we do this. There we go. Okay, let's go on a... If it would stop moving, that would be wonderful. Let's go on a cruise. Okay, I wasn't as bad as last time, okay? This time I was nice. So, we're going on a cruise. Well, I'm going on a cruise. And I'm taking an apple. A simple apple. Let's hear. A banana is staying. Lamp is staying. A tart is staying. A table is staying. An avocado is going though. Avocado is going. Marlene, you're going with me. Poo, 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 poo. Everyone else? Abracad. I get it, guys. E. Asparagus and apricots are also going. But I'm also taking an egg. I think you guys think that the trend is the A. It's not. Abracadabra is not an object, Alice. You are cheating, Manje. You are hypnotizing me to take you to the cruise. I see you. Me, I see you. Mind games. Food is not the trend either. Anybody? Toast is staying. Are we figuring this out, my darlings? I'm also taking ink. Tea is staying. There we go. Marlena's figured it out. It's words that start with a vowel. Yay! Wasn't I nice on this one, guys? I feel like I was very nice on this one. Are we ready for round two? Ready for round two? Let's go with round two. Okay, let me erase these guys. Abracadabra is not an object. You must take an object. Okay, let's think. I'm going on a cruise and I'm taking watermelon. If my handwriting can cooperate, that would be wonderful. I'm taking watermelon. Chicken is staying. Waterfall is also staying. Mango is coming with me. Marlene is hell bent on going on this cruise. Marlene's like, I'm not staying today. A melon, depends on which kind, but yes, it can go. It can go. Banana is also going. Strawberry. Okay, I'll tell you later why I have doubts with strawberries going, but they're going for now. They're going for now. Anybody see the trend? It's not what you think. Carrot is definitely staying. 100%. Ellis, grapes can go. Grapes can go. What do you think, guys? What's the Jason, you still haven't guessed the trend. Is it fruits? No. A, no. I'm looking for someone who's gonna deviate and still get to go. Like someone who's not gonna pick fruits and still go. I just wanna see something. Gold is staying, 100%. I'll take the gold, but you're staying. A pillow is staying. It's not so easy, guys, is it? A blanket staying. Money is also staying. I'm sorry. An ape is also staying. I'm not going to give you a clue on this one, guys. You said you wanted a difficult one. It's actually not that difficult when you see what's going on. Try to deviate from fruit and see what happened. Toast, tomato, staying. Basket, staying. Milkshake is going with us. And I love milkshakes. A smoothie, I mean, you can come. You can come. It depends. It depends, though, but you can come. Alice, I want to hear you pronounce that word that you just typed now. Juice can also come with us, but it also depends. Water is definitely staying. 100% staying. Oh, the trend. It has juice. No, it's not that difficult. Yes, it's sweet. Sugar and cake are going, guys. It's the sweetness. You could have said donuts. You could have said, I don't know. That's why I'm saying these people, guys, strawberries for me are sour. I don't know. I don't know. I don't know. I'm yet to have a strawberry that I was like, it's delicious. No, 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 no. Every time I have a strawberry, I get hit with the sour ones, and I'm like, ah, can't why do people like these things? Why do people like these things? Strawberry is shaky. Maybe I don't know. I'm gonna taste the strawberry before you board, and if it's sour, you're staying. Ah, kind of sour stuff on our even smoothies. Even the person who said smoothie, if it's one of those green smoothies with kale and what do they put in smoothies? Hey, you guys are creative. Those funny green spinach, you are staying. Yeah, right. Okay, I've recovered, guys. I'm sorry. I've recovered. You guys are just laughing at me. I'm going through it, guys. I'm going through it. Whew. Speaking of green smoothies, I'm gonna go make one when I leave here. But it's fine. Okay. Let's do another interesting example, guys. Let's do another interesting example. Oh, would you look at that? A 2-liter carton of milk excuse me, must fill small plastic cups. It always tastes horrible, actually. I just take a deep breath and down it. That's how I go through it. I'm yet to have a green smoothie when I'm like, oh wow. No. Mm. Oh, that's smart, Alice. Maybe, huh? Okay. We're getting somewhere. Alice is giving me guys. I mean, I was road dogging it. I was putting spinach. What else do they put in there, guys? Ish. Hey. Cucumbers, but cucumbers don't have taste. It's just water. I was just so I just take a deep breath and then I cry a bit, one tear, and then I'm like, right, down it, fast, fast, before you die. Okay, guys, we're talking too much. We're talking too much and laughing too much. Let us do the 2-liter cartons of milk, which needs to fill plastic cups. I don't know who is serving milk to their guests in plastic cups, but it is what it is. Okay, that's where we are now in life. If the small cup is only 100 milliliters, this person is even stingy, guys. You only get 100 milliliters of milk in my house. Yeah, I shame. How many cups can you get from a 2-liter carton? Okay, let's see how many people we are giving milk. They do, and I also do drink milk, but it's flavored milk. I always drink chocolate or vanilla flavored. Not just, guys, people who drink milk for fun. Hey, you guys must tell us what's wrong. We can talk, guys. You can open up to us. Achille is giving me scary vibes over there. It's a scary business. Okay, we're talking too much. Let's start off with conversions. Okay, we have a problem because the cups are in milliliters and the carton is in liters. So we have to convert one of them. And Jason is correct. Jason was busy working while we're busy talking about milk and crazy people. Okay, 1. Let's first convert our 2 liters to milliliters. So remember, 1,000 milliliters make up 1 liter. So if I have 2 liters, how many milliliters will that be? If I have 2 liters, then in milliliters would be 2,000. So then my 2,000 milliliters divided into cups that fit 100 milliliters, that is indeed 20 cups. And that is a I'll never see you again for giving me milk. 20 cups. That time you have 5 guests. Yeah, each of you can drink 5. I'm kidding, guys. Okay, suppose that the capacity of a small cup is 0.12 liters. How many full cups can you get from that 2 liter? Interesting, né? Okay, we actually don't need to do a conversion here. We can just use them in liters. So if I say 2 liters divided by 0.12, how much does that give us? 2 liters divided by 0.12. I know it's going to give us a decimal. I'm pretty sure. So that's 16,66 cups. But they asked us how many full cups can we get here. So how many actual full cups can we get? 16. Nice, Maureen. 16 cups. Okay, that wasn't that bad, was it? I must give you one that's a bit more interesting. If someone gives you milk at their house, you should know you're in a horror film and you should run. Guys, there's something worse than milk, but I'll tell you after the lesson. There's something worse than milk that you can be given. And I experienced it, but it's very personal, so I'm not going to record it. Okay. Let's do something more interesting, eh? Guys, you guys are sleeping. There we go. There we go. Let's see. We want the area of this shape. Now, what are we working with? Jason. So we have a rectangle and we have how many semicircles? A 1, a 2, and a 3. There we go. So obviously, we first start off with the area of the big shape, which is your rectangle. So I'm going to say area of the rectangle. And that's easy enough, length times breadth. What's the length of this rectangle? My length will be 9. Thank you. 9 times, what's the breadth of this rectangle, or the width? That will be 6. So it's this 4 plus 1 plus 1. And then 9 times 6, what is my area of this rectangle? 54, and it's in centimeters squared. Now we have to figure out these three, guys. Okay, so I'm going to go ahead and ask you guys again, if I do this and I do with that, what does that look like to you? Those two semicircles. It's one full circle. Do you guys see that? It's one full circle. So I'm first going to start with area of circle 1. And that is pi radius squared. Now what's the radius of this circle? 3,14. That would be 2,5 squared. Great. Let's figure out the area of that circle. Are you sure? 3,14 times 2,5 squared. There we go. That looks a bit better. 19,625 centimeters squared. But we still have a third semicircle over here that we have to figure out. So I'm going to say area of semicircle. Is my formula correct? What do I still need to do? Thank you, Alice. Half of that. So this will be a half of 3,14. What's the radius of the third circle that we are working with here? It is indeed 2 centimeters squared. So what's a half times 3,14 times 2 squared? That is 6,28 centimeters squared. Great. Now to find the area of the middle part, or the shape that we're actually looking for here, we're going to, let me say, total area equals, let's see, it's the 54 minus the big circle, which is 19,625, minus the semicircle, which is 6,28. What is our area? $28,095. But they did say correct to one decimal place. So I'm going to round it off to 28, what? 1 centimeters squared. Alice, if you add the 0 in a test, they might take a mark because that's technically 2 decimal places. Okay. They're called significant values. You'll know about that in university. So that 0 would be a problem. You would just have to have 1. Okay, can we get a thumbs up, thumbs down on this one?